Hello, welcome everyone. Today's video I'm going to be sharing with you with one major concept that you cannot do away with, or you cannot continue with automation if you don't know about. So it is very simple and it's very basic. So we talk of normal closed and normal open. Normal closed and normal open, they are these switches. So I got this. I'm going to show it to you when I'm done with setting it up. It has the push buttons, and these push buttons, they are the momentary push buttons. The push button you press and it goes and comes back on its own. This is the type I'm talking about. So you place it and comes back. You press it, comes back. So it has something of like a spring inside that pushes it back to its normal state. So whenever you get a push button, sometimes you'll find it is normal closed and normal open. Like here, there is a symbol of normal closed. This red is normal closed. So the whole concept is when you have a normally closed switch, whenever you apply any volts, say plus 5 volts, you immediately get it here. So when I get to like this and I find it is a normal closed switch, so that means initially when there is nothing applied to it, its input is the output. In actual sense, it is like there is continuity. So if I test for continuity, if I go to my multimeter and I select continuity, this continuity, it should be producing a sound. So if we hear a sound, that means in its normal, in its normally open, when we have done nothing to it, it should be producing a sound. So, and it is the contrary to when I get the green one, the normal open. I think you can guess the difference. So with the normal open, I will get my output. With the normal open, I get my output when I close this, when I push a force. And with the normally close, I get my output even before I put the force. So in the normally close, once I place, now I break the circuit. So this is what I'm trying to illustrate is operating. So in this kind of a circuit, this is the one that I was having on the board. We have the start button, but when I press the start button, let me simulate. I go into simulation. When I press the start button, the lamp is lighting. And realize that when I release over, it is going off. But this is not the kind of a system we want. That's not the kind of a system we want. The kind of a system we want is like whenever I place this, it keeps on, even though it comes out itself. So when I go to the PLC to illustrate it very well, let me go to the PLC. I have these two types of programs. One program is like the same way we have seen for the wiring, that I will start this button and then my lamp will go on. But if I release this button, my lamp will go off. But now I want it in the other way around, that when I press my start button, my lamp goes on, and when I release my start button, my lamp stays on. This is what I'm trying to mean over here. Uh, so now I go here to simulation, and then this is what I mean. What I want is when I press my start button, to keep on this condition one, I don't want it. I don't want this condition. You can see like when I press my start button, this lamp worked, but in this kind of a scenario, my lamp worked, but it went off when I released, when it is released, but this lamp got maintained. So this is what we call hold on. And in wiring, they normally say hold on, and for us in PLC, we normally consider it as latching. So I use the output signal here to bypass the signal over here. So in wiring, I again can achieve it. So when I go back to wiring, I can still achieve the same when I'm not using a PLC, when I'm just using wiring. So when I'm using wiring, that means I have to bring in another component, which is called a contactor. So when I bring a contactor, remember a contactor is having two types of, it has six input signals, and you know the input are three and then the output are three. That is a three terminal one. So if the three terminal one, it has the input three phase and then three phase output. But then it has the auxiliary terminals. Those auxiliary contacts, they are normal closed and normal open. So I get one normal open contactor because when I energize it, the normal open will become normal closed, and it will help me to bypass this push button. So this is what I'm trying to mean. So again, go back here, I simulate, and now this is the second case that I want. For the second case is I'll place this, then when I release, you can see it is still showing that it is on. This is because when I placed this, the normally closed, the normal open of my contactor became normally closed. And once I release this, now the electrical path is still finding this here, over here, until I place stop over here, and then everything gets de-energized. So uh basically, you can implement this without using a PLC, but what I was trying to bring to you is the attention of like the momentary switches, and then the whole concept of momentary switches, and then how you can do the latching and hold on. So in control wiring, you will find people calling it hold on, and if you go to wherever, you find people calling it in PLC, we call it latching. So I'm going to assemble everything. So this is how you just buy everything. For my start, let's say of any motor or anything, I'll just buy these two switches. So I'm going to wire it up, and I show you how what I was meaning using my lamp over here to make it a little bit more practical. Thank you.